Hello, welcome to this lesson in Calculus 1 limits. What we're going to do now is continue to solve simple limits using substitution. So let's use the concepts we learned in the last section to solve the following limit. What is the limit as x approaches the value -1 of the function x plus 4? Now, the way you handle this is you assume, first of all, that you don't know anything about this function. And if you don't know anything about it at all, the easiest and simplest way to handle this, and what you'll be doing in the early parts of learning about limits, is you'll make this table that I've mentioned for you. And I know it's a little bit boring, but really it's the bulletproof way if you don't really have any idea what to do. And that's, in the beginning, that's what you want to do. As you get some experience, you can use some other techniques. So we're approaching the value of -1. So first let's start at 0 because that's close to -1. If you put a 0 in here, you just get a value of 4 back. Okay? Now we're approaching -1, so let's go negative. If you move yourself to -0.5 and put this in, you'll get a value of 3.5. And if you get, again, closer to 1, 0.75, -0.75, you'll get 3.25. And if you move over to -0.9, you'll get 3.10. -0.99, we're getting very close over here. We get 3.01. Finally, we're going to stop 0.999, getting very close to -1. You get 3.001, and you can see how the function is behaving. We never get exactly equal to -1. We get very, very close, infinitely close. And as we do that, the function approaches. You can see it converging. We said that converges to the value of 3. So we say the limit of this function is 3. So when we write this down, we say the limit as x approaches -1 of x plus 4 is equal to 3, and that's all you really need to circle on your paper. All right. Now, as we do this, we're going to do tables in the beginning to give you kind of an understanding. But you can see that as it approaches -1, you kind of take and extend this guy. If you actually were to just plug in the value of -1 into here, -1 plus 4, you can see that it's basically going to give you a value of 3 back, which is exactly what we calculated. The reason that it works in this case where you can just take the value and plug it in there is because this function is smooth and continuous around the value x is equal to -1. If you were to plot this, you're going to get a line. The y-intercept is given by this. The slope is given by the number there. You know how to plot lines. You can plot that line and you can see that it's smooth and continuous. There's no jumping around, no sharp corners or points around the value of interest that we care about. So in those cases, I'm kind of doing a little bit of foreshadowing. You never learn this early on when you study limits. But the bottom line is if the thing is smooth, you plug in the value, then you can get the limit that way. But in the beginning, we also need to do the table. All right, what if we want to find the limit as b approaches 0, doesn't matter what variable we use, of the function 2b plus b squared. Now, you may not know what this looks like. In fact, I don't know what that looks like right now. I can take a guess, but I don't really have a visual image of what that really looks like. So if you have no idea what to do, you make a table, especially in the beginning when you're studying limits. So f of x is equal to 2b plus b squared, and we're approaching the value of 0. So we'll say that this is approaching the value of 0. So we want to start far away from 0. It doesn't matter where you start. Let's pick a value of 2. If we stick 2 in here, 2 times 2 is 4. If we put 2 in here, 2 squared is 4. You add them together, you get a value of 8. We're approaching 0, so as we move down to 1, you can put this in here, and then I believe you'll see that this is going to equal 3. You get closer, so we get 0.5. You get 1.25 when you plug that in. 0.1, you'll get 0.21. 0.01, you'll get 0.0201. And then we're going to stop here. 0.001, getting very, very close to 0.